HVAC 360, episode number 7, Greffen Systems. Welcome back, everybody, to another edition of HVAC 360. I'm your host, Matt Nelson. Today we're going to be talking with John Palsgaard of Greffen Systems. Now, if you're not familiar with Greffen Systems, they manufacture a system that retrofits onto boilers to increase some efficiencies and to help out to save energy. I don't have too much else to say. This is the last interview that I did at the HR Expo 2010 in Orlando, Florida. So I hope you enjoy it. And let's get to the interview with John. All right, we're here on the floor of the HR Expo in Orlando, Florida, 2010. I'm talking with John Palsgaard of Greffen Systems. And John, can you explain a little bit about what Greffen Systems actually manufactures?
Okay, well, what we have is principally, our principal product is a microprocessor-based device that works with hot water boilers, closed-loop hot water boilers. Typically, hot water boilers, which are very efficient and operate very well compared to alternatives, still have some areas where they can be improved on for efficiency, and we work with that, principally with boiler cycling. So what our product does is we match demand to boiler operation. Typically, we can cut 30 to 50% of the duty cycles out of a operating forced draft boiler, and with that we get energy savings anywhere from 10% up into the 20% range.
So now, how many boilers do you typically can a system like this handle?
The unit is installed on one boiler, so one per boiler room, or one per boiler. We've got we're installed in the boiler room. Our instrumentation is applied to the boiler, and we tie into the controls for the boiler. Everything is local to the boiler. It takes about 2 hours, but there is one required for each boiler in the boiler room.
Do they have to communicate with each other? Is there some sort of interconnecting communication that goes on?
No. Each one operates independently, and they work very well together in teams or in series, or they work independently on a single boiler on a standalone basis. But there's no communication path talking between the two.
Now, how exactly does it reduce the cycling?
Okay. Typically, we do it by matching boiler demand to building demand to the boiler operation. Typically, a boiler operates around a variance on a thermostat. So when there's excess capacity in the system, which is a lot of the time with boilers, what you'll have a boiler coming up to temperature, and then you'll have it turning off, and that's creating a cycling. So you'll come up to temperature in the morning, and the boiler will then start to hunt around that temperature. Typically, a variance on a thermostat is 5 degrees to 10 degrees is a typical range in the U.S. for boilers. When that happens, every time a boiler shuts off, there's efficiencies that are lost, and that's due to the fact that, number one, for the forced draft boiler, you've got purge cycles. Purge cycles are required to purge the combustion chamber of combustion byproducts before the boiler can fire again. So when that's happening, and that can be from a minute to a minute and a half for a boiler, you're blowing cold air across your very efficient heat exchanger. The heat exchanger is still working. It's just working in reverse for you and blowing warm air that you've just heated up, cooling the water, warming the air, and pushing it up the flue. So that's the waste stream really that we're looking for, and that's where we gain our efficiencies.
So how long does a typical installation? I mean, when you talk about the actual installation of the piece of equipment,
2 hours.
2 hours
Typically is the typical installation in a boiler room, and that's to put it in, to install it. A big part of that time is then testing the unit. We'll test every unit, making sure it's working and making sure the boiler is working with the additional control. We don't remove anything when we put in our system. We work with BMS systems. We work with boilers that are controlled by aquastats. those controls stay the same. The operator, there's no operator training required because the operation of the boiler remains the same. We're dynamic. We adjust to a BMS changing the boiler or an operator changing the temperature on the thermostat. We monitor and adjust our operation to what we see based on our observations of the boiler and the boiler water temperatures. But as far as installation goes, about 2 hours, and then we do test it up and make sure it's running, and that's included.
So you have a main box that's actually kind of mounted on the boiler itself?
That's it. Our processor is a single box. Our preferred point of connection is the back plate of the burner control. Generally a Honeywell 7800 or FireEye 110 or Fenwal. It's the burner control device that's our preferred point of connection.
And after that, you have two water temperature sensors that
the two water temperature sensors are strapped onto the outside of the pipe. That's actually an integrated circuit temperature sensor, and that feeds data back to the unit. We pull temperature data every 10 seconds or anytime there's a change of status on the thermostat circuit.
Now, as far as the designer is concerned, what do they need to be aware of as the engineer? Is it just something that they would specify to be mounted on the boiler, or so it's just like an accessory that you'd specify?
Well, the bulk of our installations now have been retrofit.
Okay,
we do very well in the retrofit market. As far as specifying us with new construction. We're certainly able to be specified and installed. We work with installers. We've got a group of installers covering the nation who distribute and are trained in installing these. So we do recommend that it be installed by someone approved and certified to install the device. But it can certainly be spec'd out, and they can contact us to get information on how to specify.
Okay. Now, as far as the boiler complexities, one thing that I've seen is that a lot of times boilers are getting more and more intelligent. They like to think for themselves. They don't like to be controlled by the BAS. So how does this, again, I guess, what is it doing? Is it prohibiting it from starting or restarting and just delaying that? Is there interrupting a contact for boiler start? Or
we've got a normally closed relay that's put on to the thermostat control circuit of the boiler. So the typically, as I said, the 7800 or the 110 will have a thermostat control circuit that's generally the circuit that has the limit switches for the boiler. On BMSs, they will have the enable switch if it's BMS enabled, and that circuit also would be used by the BMS if it's actually generating a control signal. We don't generate a control signal. We're a normally closed relay that operates to hold off a signal. As far as, and that's how we affect boiler operation. We don't impact the burner operation directly in the sense that if it's a modulating burner, modulation is still taken care of by the burner. Shutting down the burner, determining what temperature is reached, is still done by the existing controls, and those remain fully operational. A lot of systems now, or most systems, are going in with outdoor temperature reset, for example. We read when that temperature is reset by observing what's going on with the boiler, and we're not taking an active role. So in general, by far, even with the more sophisticated controls coming into play, boilers are still operating in the conventional fashion in that, number one, they're using the same controls, 7800, FireEye 110. And we, in a sense, don't manage the burner while it's operating. This is getting a little technical, but we manage the off time between the boiler, between firings, actively, and so there's a little bit of a difference. We don't generate a control signal, so in terms of permitting and everything else, we're technically we're not generating a control signal. So we're just operating a relay on a circuit that's designed for that, which is that operating circuit.
So if a boiler is running, you're not going to shut it off. It's when it shuts off that you prevent it from restarting, essentially.
Correct.
Okay. Now, as far as the origins of the this system and the Greffen system. Where does it come from?
It's a European technology. There's right now there's over 4,000 of these already installed over in Europe. We received UL approval in April of 2009, and we're marketing it here in North America.
How long has it been installed over there?
That's a good question. Probably actively about 3 years, 3 and 4 years.
Okay. And in the United States, how many installs did you say?
Over 40 sites right now. Mm-hmm. So that's a mixture of pilot sites that we ran, and then we have started selling the product and installing it for customers just on a normal sales basis.
Okay. Now, what is there any the setup for these devices? They're pretty much done by the by whoever the installer is.
Absolutely, it's set up pretty much with default conditions. Orientation consists of basically showing the operator what the lights are doing, and the annunciator lights, in terms of telling us what the operation is doing at different stages and what it means to the customer. Really, there isn't a lot of user training involved. We have a training program for the installers that we go through ahead of time.
Okay.
But they show up ready to put the devices in and train the customer. It comes with a 3-year warranty. If there's any questions, we certainly offer support also during that time frame if there's any questions coming up.
Okay. So again, mostly retrofit applications right now.
Retrofit applications, because those are more immediate. Certainly, design is there. It's just lead time. And
right.
Since we've only been here in operation just a few months, we don't have a lot of active designs going in. But
sure,
this interview will help change that.
I think that's unless there's anything else that you have or that you know about that you'd like to kind of help share with us.
No, other than the fact that in terms of gas technology, we have an opportunity here to take something that's been developed across the pond over in Europe and bring it over. We're down the learning curve. It's in terms of energy savings. There are a few things that we can learn from Europe, and this is one of them. It's been a real interesting exercise in bringing this technology over. There are differences between the U.S. market and Europe in terms of HVAC, but in this case, every application that we put this into, some of them new, reheat, for example, we continue to operate well. So it's a well tested system, and it's a well tested technology, and it's got a huge potential here in the U.S.
Definitely. Now, as far as energy savings goes, what can the owner, the end user, expect to see? Is it utility bills? Is that their main focus, or I don't know necessarily how you would test on a case by case basis on what kind of efficiencies you're getting from?
If you go to our website and look at some of the pilots, when we run a pilot, because we don't remove any existing controls, if we bridge our relay, we're actually able to put a pilot together that gives you a side-by-side comparison. If we run a 60-day pilot, we will have 30 days on and 30 days off, and that's alternating, 1 day on, 1 day off, 1 day on, 1 day off, so we get a fit of balanced sampling. And that's how we determine what the savings are. And we're being third-party tested now by several utilities, and they basically adopted utilize that same feature to do their testing. So when you look at our pilot results, you'll see savings in the ranges of 10 to, as I said, as high as 30% in some cases. And that's as a result of measuring on a side-by-side basis what we've done. That's not just installing in November of this year and comparing it to previous Novembers and adjusting for temperature. That's actually comparing side-by-side information.
Okay. Now, where have I guess across the country, where have you primarily been installing these?
Oh, well, we've installed these. Our first pilot was in Southern California. We've installed it in Atlanta, Georgia, a military base in Florida, a major car rental company up in the Northeast in Boston, Logan Airport, schools located in Chicago, in Detroit, Minneapolis, Minnesota, St. Louis, Missouri, Dallas, Texas, Oakland, California, Orange County. So
Okay.
we've covered the country in a wide range. We've done schools, we've done office buildings, we've done hotels, we've done in a wide range. So we came over here with the objective of trying to prove the technology in different areas. And in the U.S. market, everybody wants to see it in their region because everybody's region is different in the HVAC market, not only weather-wise but just local practice. So we took an aggressive approach to get this out. Probably half of our first pilots were done with the CE unit, the original CE unit prior to our UL approval, and then the last half with the UL approval. The logic and the chip are all the same, so and the results have been the same.
Any hurdles with the first units? I mean, as far as or the pilots rather, getting them started, getting them installed. Anything that trips, that could affect a installation of this equipment?
No, they're just some very basics. We utilize a technology called opto-isolation. We have opto-isolators that allow us to look at circuits. They're very ground sensitive. So just there's some basics. We need to be sure that we have a ground that's tied down. A floating ground is not a good thing. It shouldn't be in the field anyway. But we make sure that we've got a good ground. We make sure that we put the sensors on the right. If we get the sensors reversed, it doesn't work. But other than little things like that, there's really not. It's not a complicated installation. We have rarely, on occasion, run into a case where a BMS is set up with monitoring capabilities and might alarm us if we go into save mode, might provide an alarm to the customer that either shuts down the boiler or is just a nuisance, and that requires generally just a slight programming change on the part of the BMS so that it won't alarm off when we're operating. So it needs to know we're there.
Right. So it's essentially sending a signal to start the boiler, and the boiler's not starting, so it's sending an alarm.
Correct. And but generally that's not the case. So that's rare, and that's easily fixed.
All right. Well, I appreciate your time, John, and from the floor of the HR Expo 2010 in Orlando, Florida, and we'll talk to you later.
Thank you.
Thanks for listening. I hope you enjoyed that interview with John Palsgaard of Greffen Systems. I'd like to thank John for spending some time with us out of his schedule to talk a little bit about what his product and what it does. Now, Greffen doesn't have the corner on this market. I know I've seen a couple of different other products out there that do something similar, maybe not exactly in the same way, and maybe not as easy as the Greffen system. That seemed pretty easy to install, and like John said, it was pretty painless and didn't take too long to retrofit it into any sort of application. So I'd just like to thank everybody for listening. I really appreciate you, and I think we're doing some great things. We're going to have some great interviews coming up now and in the future. If you have any comments or want to give me some feedback, you can send that to me either at the blog at buildingx.co, or you can email me at matt@buildingx.co. If you want to follow me on Twitter, my handle is buildingx. And we're on iTunes, so if you heard us on there and you like the show, why don't you go ahead and leave me some feedback there. I'd greatly appreciate that. If you did enjoy the show, why don't you share it with a friend? Send an email, send a link, talk to them around the water cooler. Let them know that where we're at and how to listen to us. So, until next time, remember, know what you build and share what you know.